No.
Who remembers what it meant if a function also passed a horizontal line test?
Oh, that it had an inverse function.
That it has an inverse function. Okay. Take a moment and go with me here and just think about this for a second. Really, really concentrate, okay? When you're putting together a function is always just made up of operations. Y equals mx plus b. You got multiplication and you got addition. Okay? Parabola. Y equals ax squared plus bx plus c. You've got multiplication, you've got addition, and you've got one thing being raised to a second power. Okay? When you invert a function, you're also switching what's happening to it. The inverse of a parabola, x squared, became a square root function, right? You guys remember that? The ballerina, x cubed, became a sideways ballerina with a cube root. So you're always switching the function. So, well, some people think one way Napier knew that logarithms had to exist was because this function passes a horizontal line test. That means it has an inverse function. We can graph the inverse function. To invert a function means you switch what?
No.
Keep going.
Exponent.
Without the exponent, you switch the x and the y.
X
Okay.
and y.
So if y equals n to the x passes through 1 comma 1 over n, what does y equals log base n of x pass through?
Would you switch the x and the y?
Switch the x and y points. So what's the switch of 1 comma 1 over n?
Is it going to be?
1 over n comma 1. Let me put some points over here.
Is it going to be upside down?
No, they don't exactly go upside down. What they do is they get rotated 90 degrees and then flipped, but that's not necessarily helpful.
So it's going to go up instead of down.
Well, here's 1 over n. Here's some little reciprocal, on the x-axis. And here's 1 on the y-axis.
I don't get how that's 1 over n though. Like what? Oh wait.
And actually, I'm sorry, this is -1, so I'm putting that in the wrong place. Well, let's,
So I was right. It is down there.
It's down there, yes, I apologize. 1 over, well, let's say n was 2. This would be 1/2. Let's say n was 5. This would be 1/5.
So you're saying that the n is, the n is 1, you're saying?
Yeah.
So
When x is -1, it makes a reciprocal of whatever this number is.
Right, but how come we only go 1/2?
I'm not. I'm just pretending it's somewhere in there. It's going to be something less than 1 as long as n is bigger than 1.
Alright.
If n is 2, 3, 4, 5, then this would be 1/2, 1/3,
Alright.
1/5. I'm not sure what. I'm just kind of making it up for an example. What do you get when you switch 0 and 1?
1, 0.
1, 0. So a logarithm passes through here. And what do you get when you switch 1 comma n?
N1.
N1. I don't know where n is because I didn't make up a number, but it's going to be this high.
Wait, is this the logarithmic function?
This is a logarithmic function. You know the logarithmic function has to exist. See, this is the weird thing. People actually figured out, they think, that a logarithmic function had to exist before they knew that a logarithm existed. Because
What are the points? I don't see.
well, the points would be, this would be the reciprocal of the base, comma, -1, okay? This would be 1 comma 0, and this would be the base, comma 1, because it's the reverse of these 3 points over here.
2 points next to each other? Going.
I was marking this on the x-axis, and that may have made it more confusing. I apologize.
Wait,
So
what happened to the 1 over n?
It's down here. The point itself is down here. I was marking it on the x-axis, and I think that was making it more confusing.
Okay.
So the 3 points I'm always interested in on the parent function become 1 over n. I'm going to do this with an example in a minute, because I think I should have done this with a number to start with. I think starting with the n is making it more confusing.
It looks fine to me.
I can't see.
But what happens is, whatever 3 points you would have found on the exponential function, the x's and y's get switched. But think about this for a minute. It seems fairly obvious that if you switch a function, a parabola, because it's y equals x squared, that you're going to have a square root in the inverse. Does that make sense?
I don't know what you're saying.
All right, that's honest.
So, you're...
So what I'm saying is they knew this graph existed before they even knew what logarithms were.
Here,
That doesn't
so
make sense.
I apologize for that. How can I fix that?
What?
Artur is commenting on the aesthetics of my ends.
We did that last time too.
Okay, now let's do an example with numbers. See if that helps. Okay, so, quick example. I'm going to graph, since my ends look like 4s, Artur, I'm going to graph y equals 4 to the x, and y equals log base 4 of x on the same graph. Are you ready?
I can't see.
First I'll make my tables.
Do you always have to make the tables?
I'm going to make you make the tables.
is this what
Do I always have to make the tables? No, I can graph these pretty quickly without it, but you're going to graph the tables for a while. Yes, sir?
Is this what a problem would look like on like the test?
They'll get harder, and I'll show you why in a second.
Alright.
Okay. Y equals 4 to the x. You said me notice here, Brian, I don't have any a, k, or h. So adding a, k, or h here is what gets exciting.
Alright.
Y equals 4 to the x passes through 1/4, 1, and 4 at the x points -1, 0, 1. Without knowing anything else about logarithms other than they're the inverse of exponents,
Where'd you get the 0 from?
Ooh, can I try it?
I always do
Can I try
-1,
Oh,
0,
right.
1.
it? Can I try it?
Tell me, Jordan.
Would be 1, and then
Oh.
1 and 2.
What would the... oh no, these aren't shifts.
Say
They're not-
the inverse, not the opposite.
Inverse, opposite, and reciprocal, the three most confused words in math.
What's the inverse?
Inverse means you switch the x and y.
Okay, then hold on. It'd be 1/4, 1 and 4.
1/4, 1, and 4, and what would the y values be?
-1, 0. Oh, that's so stupid.
Oh.
I'm-
Sorry, but like, I mean, it's just the opposite. What's the point of it?
no, actually, it's not the... Well, the point... Okay, it's not actually the opposite. In math, opposite only means switch positive to negative or negative to positive. Inverse means switch the x and y. Or slightly more technically, it means transpose the independent and dependent variable.
I don't know what transpose means.
Stick with switch the x and y. Alright? And reciprocal means, well, I'll just say it means flip the fraction. More technically, it means find the number which you can multiply the original number by and equal positive
Well, we're not
1.
flipping anything
But
there.
I mean,
We're just switching them.
Literally the opposite graph. Oh, sorry.
Inverse. Say inverse. Please start saying inverse. Thank you.
But it's the same thing.
If you keep saying inverse, Jordan, I won't have to kill you.
No, it's not the same thing as.
Okay. So I've got to go 1, 2, 3, 4 in both directions for this. And I need a -1 in both directions. Okay. The original graph, the simple exponential growth, will pass through -1, 1/4, which I think is about there. Pass through 0, 1, which should be exactly there. We'll pass through 1, 4. And we'll have the standard airplane taking off until it goes horizontal and crashes.
So I mean, wait. I have a question. Since you always switch them, so is that one? Is the opposite going to be down in the negatives? But like that one.
Well, you tell me. Where's the point x equals 1/4, y equals -1, Mimi? Where is it on my graph? What do I do?
The opposite of that, of the first,
Stop saying opposite. Alright.
down there.
Down there, I'll accept that. I go over 1/4.
Wait, is 1/4 smaller than 1?
No, because on the other one you went to
Really,
this.
Jordan?
You put it like right on the 1.
You
Jordan,
did.
I'll give you I'll give you a bright shiny quarter for $1. Is that good? A good trade for you?
Look, you put it right on the 1.
You did. I agree with her.
Okay, guys.
No, the
1/4 is the y coordinate, so it lines up with this smaller y value.
Never mind.
Now on the inverse, not opposite, 1/4 is the x coordinate, so I only go 1/4 of the way over
Oh, the one over there, Jordan, is a 4.
and then down.
Sorry.
Is the one all the way up there a 4?
This is the point 1, 4.
So yeah, never mind.
Okay. Now it passes through the point 1, 0, and lastly it passes through the point 4, 1.
Can you slow down?
Nope, we got a lot to talk about.
Oh wait, is that the
See,
second one?
is it always gonna be like that?
Hold on, cowgirl.